Alright, we're going to go ahead and get started. There's a lot that I want to try and talk through today, but I really don't know if we'll get through all of it, so we'll just kind of see how things go with this. Jonah's excitement over this is about the same as mine. I love talking about this, and in part because there's so much, this and HIV in particular, there's so much in terms of cultural, social, political, economic implications that contribute to these two diseases and the spread of them in some ways. So I think that's a really important thing to kind of keep in mind, and that's what we're going to try to spend at least part of today talking about with Ebola. The one I forgot to mention, or I forgot to ask on Monday, hey, what paper should we read for this one? So I had two up as options. The one that's listed on here is one that I've used in the past. So it's another paper on entry, and my personal thought was we've already done a couple on entry, so maybe we should move away from that. But I'm leaving it to you guys. So one is about Niemann-Pick C1, which is a protein that's required for Ebola virus entry. The other paper is one on looking at the mutation rate of Ebola virus and actually trying to use that as, or at least the idea behind it is, if you can force it to mutate, you can treat the disease by making it less pathogenic. Do folks have preference? Vote for number 1, which is this one. Vote for number 2. Okay, I guess I'll be working on a new paper. So, slides will be updated. Then I stopped at a certain point. I stopped after what I think we'll be able to get done in the first 3 lectures. The fourth one, which is going to be kind of on how Ebola affects the immune response, will be kind of our fourth part of this, and then the last part will be that paper. Sabrina.
So what's our cutoff for our exam?
The cutoff was HPV, so yes, Monday was the cutoff. So all of this is now information that will go into the last exam. So that means basically for the next one we've got coming up, it's kind of focused. It's focused on DNA, viruses, bacteriophage, and HPV. And that's pretty much it. Okay? And related. And what I mean by that are things like, we saw in the critical thinking an example of a viral cyclin that overcomes the cell cycle. That could be an example of something you might see in that exam. All right, so something that's related to what we've talked about. Let's start with this. What makes a virus successful? Or if we were to think about what are examples of successful viruses? What are they?
Spread their genome.
Okay, they spread their genome.
Compatible with the host, right?
Compatible with the host, absolutely. So they have to overcome host hurdles.
Yeah.
Spread their genome, what else?
Preferably not kill their host, just spread even more.
Why do you say that?
I mean, if you look at it for HSV, I mean, it stays in the host forever. It just doesn't kill the host, but it'll keep spreading it.
Yeah, and that's what a lot of virologists would argue. The herpes viruses are probably some of the most successful. High infection rate, not a lot of the illnesses that are associated with them are, for the most part, mild. Mono sucks, but it sucks for 3 weeks. HSV, recurring cold sores, but that is not life-threatening per se. Those would be considered successful viruses for exactly the reasons that Jonah said. It doesn't kill the host. The genome can be spread from one individual to the next fairly easily. It remains in the host for the remainder of the life. Is Ebola successful?
Very.
Huh? You think so?
I think so, sometimes.
And staying in the host cells, is that what you're saying?
Or just, is it a successful virus?
I'd say it spreads very easily.
Okay. How many people 50,000 maybe. Is that successful? I mean, our understanding of Ebola has only been about 50 years. We've only known about it for 50 years. Could have been cases before then. I'm gonna go to a slide real quick that I'm just gonna skip ahead real quick, and then I will come back. Here we go. All known Ebola outbreaks from 1976, which was the first, through 2014 to 2016. So that 20,000 number, that was surpassed by 2014's outbreak alone. 28,000 cases was about where it left off. But compare this to all the others. 57, 149, 264. The most of all of these, 425. There have been fewer than 50,000 cases of Ebola lifetime. Now, I would argue, yeah, it does spread pretty easily. It doesn't spread as easily as we might think, though. So, one of the ways that we can measure viral spread is by calculating what's known as the R0 value or R sub 0 value. Ebola's is 2. In other words, for every one individual that's infected, they're going to spread along Ebola to 2 other individuals. Measles is 16. Measles is probably one of the most successful viruses in terms of spread, because of the fact that it can be airborne for a number of hours after being coughed. How is Ebola transmitted? Not just touch. It does require direct contact, but it requires direct contact and it requires broken skin. Right? It needs some sort of portal of entry to be able to get into the bloodstream, essentially. So Ebola isn't incredibly great as a spreader. What are some other characteristics of just the disease itself? Or what do we know from the news from 2014? Many of you guys were either freshmen in college, I'm going to guess, or seniors in high school when this was happening. Grace?
I don't know if this is what you're looking for, but it's kind of concentrated in one location, I
Okay,
guess.
it is highly concentrated in one location. Most of these, before 2015, a lot of these were in small villages, actually. What else?
Hemorrhagic fever.
Okay, what's that mean, Jonah?
Can make you bleed.
Can make you bleed. If you are bleeding, will people come near you?
No.
No, it's a very frightening looking disease, right? How quickly do people die? It's pretty quick, a couple of weeks. I mean, from the onset of symptoms to death, it might be about a week or so. That would be maybe why some people might argue it's not successful. Here's the last reason. Comes and goes in waves. Humans are not the reservoir for Ebola. What is thought to be the reservoir? Fruit bats in particular. We'll take a look about some of the data that supports that later on. Okay? For an organism to be a reservoir for a disease, that virus has to, or in this case, for a population to be a reservoir for a virus, that virus has to be maintained over long periods of time. In humans, Ebola is kind of like a wildfire. It comes, a high concentration of individuals infected in a short period of time, and eventually the virus runs its course because there are no more susceptible hosts available. Either they have died, or we've blocked the transmission from one individual to the next. Okay. So that's the context for today, is to try and talk about what are some of these factors that contribute to this type of pattern with Ebola infection. One of the things that we'll point out is that the death rate is high. From one round of these outbreaks to the next, the death rate has ranged anywhere from, most recent one was probably closer to about 35 to 40%. The highest have been around 90% death. Okay, so we see wide range in death, and there hasn't been a really good reason for why necessarily, other than just care may have differed from one condition to the next.
Nobody knew what had killed one-year-old Emil Umaru. His sister died 9 days later. Then his mother fell ill. She was 7 months pregnant.
À 2 heures du matin, son mari est venu cogner la porte. Il dit, monsieur Bissette, il dit oui. Il dit, ouvre la porte. Il dit, qu'est-ce qui ne va pas? Il dit, ma femme ne fait qu'à saigner. Elle était en grossesse de 7 mois. J'ai dit, mais qu'est-ce qui ne va pas? Elle dit, vraiment, elle ne fait qu'à saigner et ça ne va pas. Je suis sorti, je suis parti, j'ai vu, elle était à la maison dans une chambre là. La chambre là, c'était pas dalassé. Mais le sang était là-dedans. Toute la maison était déjà du sang. Moi, mais j'ai eu peur. La nuit là, c'est à 2 heures du matin qu'ils sont venus me concours. À 1 heure du matin, à 2 heures, 2h30, elle a goûté ici. De la bonne, de la petite Sia. Le papa des enfants, elle est devenue fou. Il dit, oh, le village m'a tué, le village m'a tué, le village m'a tué, le village m'a tué. Il a commencé à crier. Là, nous, on se trouve en l'endroit de ma fille. Soit fou d'ama, payement à l'air au Tchaïchino, Banaya, Malandwa, Ha, Mavu. China to Chua, from the Sinapola.
A traditional healer gathered everyone together, including more family members who had become sick. A villager filmed the ceremony on his cell phone. The next victim, Emil's grandmother, left the village to seek treatment. She infected a nurse at a local hospital. The sickness began to spread across the forest region of Guinea, but for 3 months was mistaken for cholera and malaria. By March, the virus had traveled hundreds of miles and killed more than 50 people. The government sent a team of scientists to investigate and take blood samples.
Le ministère de la Santé nous a dit, attention, docteur Lamine, il y a beaucoup de personnes qui décèdent en forêt et que ces décès sont d'origine inconnue. On ne connaît pas l'origine de ces décès.
The doctor tracked down a teenager named Khalil who was sick with a mystery disease. His colleague started filming on an iPad.
L'enfant était là. Tout était du sang. Mon frère clinicien qui était avec moi, notre clinicien, il dit, j'ai vu beaucoup de maladies, docteur Lamine, mais c'est la première fois. Nous l'avons aidé à se lever, à s'adosser au mur.
Oh, sorry.
On a fait 4 minutes. Et je savais que c'était l'endroit. Et je m'avais que c'était une fièvre hémorragique. Mais laquelle des fièvres hémorragiques, je ne pouvais le dire. Il m'est difficile de parler. La main était ici. Le père assis, loin de son enfant, et qui voyait son enfant.
Carlos blood would later be tested. The results, Ebola.
À quoi j'ai pensé? Je n'y avais pas pensé. Et c'était vrai.
All right, we'll stop there. There's a lot to unpackage in this video. Even in those first 10 minutes, just the amount of information that's in there. So let's just start with a couple of basics. Discovered in 76, outbreak took place in Africa, in Zaire, which is now the Democratic Republic of Congo, in a town known as Yambuku. The virus was named after the river, Ebola. And at the time, these outbreaks were limited to small villages. Okay? And this is kind of important, and we'll talk about the importance of that a little bit later. This is Peter Pio is one of the discoverers of Ebola. He's kind of an expert in exotic diseases, and so that link there kind of gives you a nice rundown of the history and their investigation of this first outbreak, if anybody wants to take a look at that later on. One of the things that they talk about in this video is the number of cases that occurred within the first few months. And when looking at the epidemiology of a disease, we can look at it in a number of different lenses. One of those lenses is we can look at how many incidences, how many incidents have occurred, what's the prevalence of the illness. We can also determine how many total number of cases. So incidence just represents the number of new cases in a period of time. For Ebola, this is typically measured in weeks when outbreaks are occurring. For HIV, it's usually on a per year basis. Prevalence represents the total number of new cases and currently existing cases. And somebody can be removed from the prevalence only in one of two cases. They're cured or they die. So for Ebola, I shouldn't say more often than not, but about half the time individuals survive and are removed from that prevalence pool, and the other half the time it's from death. Okay. We assume that it's kind of hard sometimes to track prevalence with something like Ebola because it is such an acute illness, comes in and comes out right away. So usually we make some assumptions, for example, that somebody's going to be infected with Ebola for about 3 to 4 weeks. So usually that prevalence is a running total of the number of incidences within a 3 to 4 week period of time. We can look at this data in a couple of different ways. We can look at it in just the total number of incidences and the total number of prevalences, total number of individuals infected. We can also look at this on a per population basis, and this can actually give us some really interesting information. So here, what I'm just showing you is, if you wanted to do this, these are ways that we can calculate incidence and prevalence. This is data from early in the outbreak in Guinea, looking actually day by day for a few of these periods of time. Not until the 25th they reported 86 cases, and I think this was the time at which they identified all of the previous cases as to have been confirmed. And so it's not as if 86 happened in one day, it was kind of a back calculation from what they had seen. To calculate something like incidence, these numbers are based on a per 100,000 basis. So what you would do is take the number from a date, subtract it from the previous one to figure out how many new cases have occurred, divide it by 100,000 to figure out your incidence rate. Prevalence, again, just kind of a running total of that.
Why do you divide it by 100,000?
It's a typical measurement of unit for this, and so it allows you to compare, for example, what is the frequency in a population in the United States versus a country like Guinea where the population is 11 million. So it allows for you to compare between countries, right? So let me give you an idea of how this looks. So here is data from the World Health Organization, from the CDC, looking at the number of cases. I've just kind of put 3 time points up here to give you guys an idea of these. The x-axis just represents the number of weeks of the outbreak, or at least what we have data for. Y-axis represents individuals, so total number of individuals who have been infected. And if you look at this data, total number of individuals that have been infected in Sierra Leone is the highest. Okay, Liberia, second highest, lowest in Guinea. We find actually the highest number of deaths in Liberia, and again, still lowest in Guinea. But the percentage here of deaths in Guinea seems to be higher than the percentage here in Liberia. So this is how we can start to look at the data. So to look at it, this is just total number of cases, Jonah. Let's look at it on a per population, basically. Where is this most extreme? Liberia. That's why we might look at it on a basis like this. Because you might have a smaller country, but the number of cases given its population or the size of that country might be much larger. And so reasons why we might do this, or why an epidemiologist might do this, is to understand, well, what are they doing in Liberia that's different than what they're doing in Guinea, where the number of cases are really low? What are they doing in the medical settings? I would look at this and go, okay, so what's different about the environment of those locations, or the interaction between the individuals? These are in 3 incredibly poor countries, and at the time of the outbreak, all 3 of them were coming out of civil wars. So there was incredible destabilization of the governments. The infrastructure to support medical care was really, really poor. So that's why we might look at it on a basis like this. I think one maybe thing to point out real quick is we can see pretty easily here the worst period of time for this, and all of the, particularly in Liberia and in Sierra Leone. And it really starts to take off about 20 weeks into this outbreak. So this would have been, let's see, July, August, about September or so of 2014. And from then till the end of the year was about the worst period of time. This is when we saw the greatest number of incidences. This can maybe be a bit artificial, and that what I mean is that obviously early on, there may be cases that were missed because they didn't know what they were looking for, and that's something that gets pointed out in that video. They didn't expect it to be Ebola. What else did they say? What about the symptoms? What else did they consider to be the cause of the illness? Malaria, cholera was another one. What are some of the symptoms that they described for an Ebola infection? Vomiting and diarrhea, and that's what we call the wet phase of the infection. That's kind of the latter half. There's a dry phase, which is fever, headache, and then the wet phase would be some of those other issues. And once it gets to that stage, you're in trouble. Okay? So part of this might have been misreporting. Part of it might have been individuals that didn't go to seek medical care. I mean, we in the US are individuals that, if we have the flu, with maybe the exception of this year, I think this is the only year where I thought I had the flu and I actually went in to go get tested. Most other years, I wouldn't do anything about it. And so if you think about even our habits and our going to the doctor, that makes it very challenging to track the number of cases of an illness. These are probably underreported in comparison to the true magnitude of Ebola and the infection in 2014 to 2016. What does this fit the pattern of? So that we usually can describe diseases by location. Those were descriptions of number of cases. We can also describe these by location. Epidemic, pandemics, sporadic illnesses or diseases, and endemic diseases or illnesses. What does Ebola virus best fit? What was that?
Is it an epidemic?
Probably. Why? What are the characteristics of an epidemic? At least even from what you can note here, Grace.
It's not concentrated in like one area.
Good. It's concentrated. Usually we say epidemics are isolated to a continent. Ebola, by far, most of the cases were isolated to Africa. Now, there were the opportunities for pandemic. And those included, well, we had a couple of examples even in the US. Does anybody know of the examples that we had? Andrew?
Wasn't there a couple of health workers that were flown back to Atlanta to be treated?
Absolutely. So a couple of US health workers were flown back to Atlanta to be treated. Jonah?
There's one nurse in the US.
From like Maine or something, Maryland, somewhere on the East Coast that like refused to be isolated or quarantined for a period of time. That caused a really big uproar on both sides. And then there was a case in Dallas too. A man of, I can't remember if he was Liberian descent, but he had dual citizenship with the U.S. and a country in Africa. He went to Dallas. Couple of the, if I'm not mistaken, a couple of the nurses that worked with him were infected. That had the potential to be a pandemic. Okay, luckily it didn't. Pandemics we would describe by being worldwide, on more than one continent. In comparison, we also can describe these as being endemic or sporadic. Endemic diseases would be ones that are, we find commonly within certain locations of the country. So for example, Lyme disease is endemic to the Northeast and to parts of Michigan in the United States. West Nile virus is endemic to the Midwest during the summertime. These are diseases that come up again and again and again every single year. Okay? This would be in contrast to sporadic, where there might be one case infrequently. Okay? So for example, a foodborne outbreak of salmonella can be a sporadic case. Somebody picking up avian flu in the United States can be another example of a sporadic case. Usually sporadic cases are ones that can't be passed along from one individual to another very easily. If we take a look at specifically where this was occurring within Africa, the highest concentration was within Sierra Leone. So this is just looking at the epidemic itself from 2014 to 2016. The bars here represent the number of cases. So darker shades would represent higher concentration of cases. So Sierra Leone had some areas where there were 500 to, the bar goes all the way up to 4,000 cases. And these would be different, I'm guessing these are different provinces within each of these countries. You can see Liberia across the whole country was hit, Sierra Leone as well was hit across the country. Guinea was a little bit different. There are some areas that went uninfected. That again could be because of underreporting. Those might be more remote areas, and so maybe the isolation actually prevented spread of disease in those individuals. One of the things that was really tough about this particular outbreak was there is a lot of travel between these countries without any sort of, put it in Trumpian terms, wall to prevent people from moving from one country to the next. Okay? And so because of that, it allowed for individuals who were ill to pass across the border and potentially spread the disease to other individuals. I don't know how frequent that was, but that possibility was there, and it has been argued as being a contributor to the outbreak that occurred in 2014. This image, just real quick, I've grabbed and used a couple of times now. This just shows the potential for that pandemic. So this shows international travel. All right, so this shows international travel from the countries that had infections: Liberia, Sierra Leone, Guinea. Nigeria did have a small outbreak too. There were actually 20 cases, but they put the kibosh on that really quickly. They had an incredibly strong medical response to it that blocked further infection. But what they're trying to point out here is here are the countries in which the infections occurred. The purple lines represent all the countries where there were flights to other countries. So this just gives you an idea of what the scale of the pandemic could have been. Okay, so for example, there's Atlanta. Here's the one up in, I guess that would be Maryland, wouldn't it? Maine's up here, and then Dallas. There was a priest that was sent back to Spain who was infected. We had healthcare workers in Ireland and England, France, Germany, and some of the other countries in Western Europe as well had healthcare workers who were infected that had traveled back home. Luckily, I suppose, that the cases didn't extend beyond outside the main pandemic area. One of the things that I want to go back to real quick, this says, there's this little bar down here that says cases reported in the last 21 days. Why is 21 days important? And actually our book refers to what they call the 42-day rule. Anybody want to take a guess as to the importance of those numbers?
So when they start showing symptoms?
Yeah, that's what we would describe as the incubation period. All right, so the incubation period for Ebola is thought to be anywhere from 2 to 21 days. And this slide is basically showing you that we can describe diseases by the illness pattern as well. So that's where we're transitioning to now. So the incubation period is a period of no signs or symptoms. An individual at this point usually is not infectious because the amount of virus is too low to allow for the spread of the infection from one person to the next. Average number of days was about 9. But you could observe signs and symptoms of illness as early as 2 days. 21 was the maximum. And so there was this idea that, well, if we say if there are no cases in 2 times the incubation period, 42 days, that's when we'll call the outbreak over. And that rule was pretty much followed, and I think the last number of cases occurred in early 2016. Most diseases take this general trend, or at least most acute diseases take this general trend. So on the x-axis is just arbitrary time. Y-axis represents the amount of microorganism, or in this case Ebola. And an individual will first go through a prodromal period where they might have some very mild symptoms. This is where, like, if you had flu, you might start to feel a little off, we might describe it. And then illness for Ebola lasts about a week. This is where we see the transition from just very general, non-specific symptoms to more non-specific symptoms like fever, malaise, fatigue, maybe a little bit of aches and pains, grogginess. Later on, it becomes more severe. Vomiting, diarrhea, bleeding. Bleeding is not associated with all cases of Ebola, though. It's one of the most lasting images, but it's not associated with all cases. If an individual survives, we find the decline period in which the number of viral particles decreases. Usually this is because our immune response is able to control the infection. Somebody is still infectious during this period, and they can still be infectious during what we call the convalescence period. Convalescence is a period of time where signs and symptoms are largely gone, but the virus may still be there. It still may be infectious. And we did see in some cases of Ebola that this convalescence period lasted up to 6 months. So there were reported cases of males who were infected, 6 months later somehow infected their wives, and they found out that, holy cow, Ebola can survive in semen for up to 6 months after infection. That's the longest documented number, but that seems to be rather rare. I don't think that's the norm. Here are those different stages that we were talking about a little bit. So about 7 and 9 days, this would be your prodromal stage. Joint pain, sore throat, fever, headache, yada yada. This is also kind of your dry stage. Here becomes the wet. So vomiting blood, not two different things. Vomiting blood, single word, that's even more frightening. Diarrhea, high fever, extreme fatigue, brain damage, bleeding from the nose, mouth, and anus, and then coma, organ failure, shock from a drop in blood pressure, massive internal bleeding, death, possibly. One of the features of Ebola virus is that it causes blood coagulation. We don't really know how. One of the things that's really tough with Ebola, and this is something that we'll kind of get into, we experience the same issues with it that we do with studying HPV. There's not a great model. In bats, the reservoir Ebola doesn't really kill bats. They don't have a strong immune response to it, and so it doesn't serve as a good model organism. And what we'll talk about a week from today is how we can play with the genetics of Ebola a little bit and actually make guinea pigs susceptible to Ebola virus infection. That's about the best model that we've got. It's not perfect, though. And so because of the lack of a good model, we really don't know what contributes to the disease symptoms that are associated with Ebola virus. We have guesses. We don't really have a very good understanding. Sabrina?
How long did it take them to like track it back to that tree?
I think it took them, I don't think it was until, they knew by 2015, but when in 2015 they knew, I don't remember exactly.
So did they know before this that it was carried in bats?
That's a really good question. There was always suspicion, and there are some really good books on this. There's one that's just called Ebola, and actually, can we talk about that? Because this is the next part of it. So let's talk about why we think bats are the carriers, and then some of the evidence that we have to support it. So this is an image of Africa right around the area where these Ebola outbreaks have occurred. This is actually a Google Maps image. So you have, and here would be the cluster of countries where the infection had taken place in the last outbreak. Look at this map real quick. What do you notice about it? If you were to describe the terrain of this country, it's not what we typically think, right? What do we typically think about? Desert. All right, so you've got the Sahara up here. But this is a very vegetative location. Jungular. Not to be confused with jugular. All right. Okay, so I'm just going to let this, I think this should replay. Yes, damn, I did good. All right. So, the other image that's overlaid with this is the distribution of Egyptian fruit bats in Africa.
They're ugly bats.
They are ugly bats. What's true about these two images? If you're looking for a trend,
Positive correlation.
high correlation between where those bats are and where that jungle is located. So think about what that means then. If you're an epidemiologist and you're trying to understand how is this disease spread, right? One of the things that we know is that Ebola virus, at least this past outbreak, occurred when somebody, a child, somehow got infected after, I don't know what you want to call it, playing with a bat, eating a bat, right? And in Africa, one of the typical things is to eat bushmeat. Bushmeat is you go out into the forest, you kill an animal, cook it up and eat it. It can be chimpanzee, it can be bat, it can be another type of rodent or animal. So, one of the things that's been observed, and there's been a couple of, Sabrina, to get to your question of how do they know fruit bats, there's a couple of pieces of evidence here. One, I can't remember the researchers' names right now, but it's reported in this book Spillover by Dan Quayman. He has a couple of condensed versions of it. There's one that deals with HIV specifically, and then there's another one that deals with Ebola, and it's an incredibly good book. It's short, but one of the things that he looks at, or he talks about, is there were researchers that were trying to study, well, is it an Egyptian fruit bat? Is it a different type of bat? What's contributing to, what is the reservoir for Ebola? What they end up, the story that he tells is they end up in this cave. They look up and there are thousands of bats in this cave. And on the bottom, all over the floor, are droppings. They ended up testing those droppings. And what they found was in about 5% of the cases, there was Ebola there. But what they assumed is that the bats served as a reservoir because there was a high enough concentration that even with only 5% being infected, you always had somebody in the population infected. It's kind of like reverse herd immunity in some ways, right? Herd immunity is the idea that if we have enough individuals that have been vaccinated against a disease, we can stop the spread of the disease. This is kind of the inverse of that. If you have enough people infected and you have a high enough concentration of them, you can maintain the infection in the population. This idea of spillover theory is that individuals, and in particular we see this in Africa right now because there is expansion. There is growth in those countries. And as growth occurs, what's being destroyed? Or what are they trying to do? They're clearing land. They're clearing land for our agriculture. They're clearing land to put up houses, homes, businesses. And this drives then an interaction between humans and the environment. And these are what Dan Quayman calls spillover events. So humans pushing into uninhabited areas in search of food, in search of resources, disruption of natural habitats, destroying the habitats of those mammals, the fruit flies, and increasing their increasing the likelihood that we find them actually in villages rather than in the forest. And then development of land for agricultural events all increase this interaction between reservoir and human, thereby likely increasing the likelihood of these spillover events. It's Quayman's argument in this book that actually these account for spread of HIV or jumping of HIV from chimpanzees into humans, Ebola from fruit bats to humans, and other similar, what we would call exotic diseases. Okay. Here's then kind of that transmission, or at least how the CDC draws up this transmission. So we have individual interacting with somehow bat, and this could be through a number of means. It could be directly, or it could be through bat infects, bites, chimpanzee, cross between deer, horse, gazelle, antelope, moose, and ape. Animal dies. A dead animal is really easy to capture bushmeat, right? Human eats infected animal. Now, if you cook it, that's not the issue. It's rather when you're chopping up, if you're butchering that animal and you cut yourself, your blood comes into direct contact with the blood of that animal. That's where the exposure to Ebola comes in. And now that individual is able to spread the disease to, well, let's talk. We got a minute. What are some of the practices that they talked about that could have contributed to the spread of Ebola virus even in the early days of the outbreak?
Like, for the funeral, they like wash the body.
Yeah.
And like hand wash it and change it and do all
And
this
not
stuff,
only
like,
that, but at the funeral itself, it is important, it is part of the culture to touch or to kiss the body before it's buried. Absolutely. What else? Andrew?
I was gonna say that same thing.
Yeah. I mean, that's a huge part of it. And in this video, they talk about they brought in a traditional healer. And with that traditional healer, there were individuals who were sick that then could pass it on to other members. He said, the first father in that said that they had 3 women come and clean the house. Anybody want to take a guess as to how they were protected? Not. Okay? They weren't protected. And we don't even know what they used to necessarily clean.
Mm-hmm.
Right? Could have just been soap and water. That doesn't work. Bleach works. Yeah. And so because of these are those potential events that can lead to spread of infection. Traditional funeral practices. Unprotected healthcare workers coming into contact with blood or bodily fluid. And then going home and potentially infecting another family member. That's how we see these diseases spread. And in an area like Africa where these diseases are endemic, where we find high concentrations of cholera, where we find high concentrations of malaria, etc., it's kind of hard to tell what's actually causing the infection. What that means for Ebola is at the time when, this will be my last comment for the day, at the time when they were exploring this outbreak, they were also trying to figure out novel ways to detect within 15 minutes. Did somebody have Ebola? Did they have dengue fever? Or did they have something else? Right? So that you could die.
Ebola?
What's that?
Is dengue a hemorrhagic fever?
It is, yeah. And then you've also got Marburg virus, which is another similar family member as well. All right. On that happy note, happy Easter. I'll see you all in a week. Talk to you guys soon.
Oh, yeah, we got it.
Yeah.